First, we're going to take an algebra perspective on what a difference quotient is. If you're given a certain function and you're asked to find a difference quotient, what you're actually being asked to compute is this quantity right here. And while that may seem strange, there's reasons for this that we'll see later. But this is the definition of a difference quotient, to algebraically calculate the quantity you see there on your screen. So to get out of the abstract, let's look at a particular function for which you might be asked to do this. Suppose you were asked to do this for x squared minus 4x plus 5, for example. What I'd like to do here is take a quick look at the process here, and then we'll reverse it and slow down and look in more detail at the algebra later. Let me give you a brief overview before we get into the nitty-gritty algebra. So to compute the difference quotient, we should first compute f of x plus h and negative f of x for the particular function given. Now I've done that here algebraically, and don't try to follow every little symbol, but once you've worked those out, you can then simplify the expression using algebra until you get a result. Now, if you think your algebra skills are very strong, then in a minute I'm going to have you hit pause and see if you can track all this yourself in terms of the actual algebraic detail. If not, I'm going to guide you through it. If you're up to the challenge, hit pause now and see if you can sort of figure out all the details on your own. This thing here at the end is called the difference quotient, but now let's take a more detailed look at the exact same problem, going through all the algebraic steps. So to compute the difference quotient, again, we have to compute f of x plus h. You may see it in red in front of you. And we have to compute negative f of x before we can complete the rest of the calculation. So let's go through these one at a time. First, let's just focus on f of x plus h. What does that mean? That means to take the particular function they gave you and replace the x's with x plus h's and do all of the associated algebra. So what I've done here is expand the x plus h to the second power. You may see it in blue, and I'd like to point out or remind you that exponents don't distribute, so I actually had to use FOIL to do the blue section here. Continuing on the algebra, by distributing the negative 4 to the x plus h, I've now simplified this expression as much as I can. You'll notice that even though we have 6 terms here, none of them are alike, and therefore there's no combinability. So I have now computed f of x plus h. Now let's turn our attention to the negative f of x. I'd like to remind you that negative f of x means negative 1 times f of x. We simply don't write the times sign or the 1 in most cases. And that, with that perspective in mind, negative 1 times f of x means negative 1 times the function you were given, which, if you distribute the negative 1, works out to this. And I now have the negative 1 times f of x worked out in my algebraic expression. And now that I've worked the two functions out, I can use my basic algebra skills to finish. One thing you'll notice here is that there's a lot of cancellation. The x squared and the minus x squared combines to 0 or cancels. The negative 4x plus 4x combines to 0 or cancels, as does the positive 5 and negative 5. So after all the cancellation of terms, we get down to this. By the way, in general, when computing a difference quotient, you will almost always encounter a lot of cancellation of terms, and if you don't, you've probably made some mistake at some point. But I'm not done calculating this because I now have to divide the numerator by h. One way to do this would be to divide h into each term. Another perspective would be to factor an h out of the numerator, because then I can cancel it with the h in the denominator using the fact that h divided by h is 1 and the associative property of multiplication. Anyways, there is your final simplification here, and that's what we call the difference quotient for this particular function. Of course, any function you could be given has a different difference quotient than any other in most cases, but this is the difference quotient that's associated with this particular function. Of course, this raises an interesting question. Why do we care? What does this difference quotient mean? What does it have to do with anything? Well, for the rest of this video, we're going to look at a graphical perspective using this same example to get a sense for what this means. So, with that in mind, let's proceed.